These students may be America's mechanical engineers in a few years. Today, though, they're trying to figure out how to turn a pile of boards, nuts, and bolts into a catapult.
It looks like it's on sideways. It is on sideways. Okay.
The project is sponsored by engineering instructors from the University of Utah. They're here to pique these Frost Elementary students' interest in their physical world and perhaps spark the curiosity of tomorrow's engineers. With a little coaching,
somebody's going to have to bring it through here. Will you screw it on this side, sweetheart? Oops, okay, push it through. Good job.
The catapults take form.
Because at first the catapult kept on taking the bolt, spinning the bolt, and then when you put another one on, it's a lot tighter.
Then students must test their medieval machines for accuracy.
They're doing awesome. They've all got different design considerations, and as I've talked to each one of them about why they chose their particular design, they've had some good rationale, which is what we want out of engineers, is that if you want to design something a certain way, you have to be able to defend your design.
If catapult construction doesn't launch them into engineering, perhaps they'd like to get their hands into some slime production.
Turns into slime.
What are they supposed to learn from slime?
They're supposed to learn about chemical reactions. So here, let me see that.
If the slime reaction lacked any scientific appeal, apparently the goo at least offered some aesthetic qualities.
I just like the way it looks.
Why purple slime?
Because my favorite color is purple.
Then, how about some molecular physics? Here, these first-grade physicists assume the identity of hydrogen and oxygen molecules. Combine a pair of hydrogens with one oxygen, they learned, and presto, H2O, water. Those molecules move very slowly, they learned, when frozen.
Freeze! Perfect.
And here, sixth-grade students take those atomic particles to a new level.
We want them to learn some very simple concepts about atoms and electrons and neutrons and protons, and simply by moving electrons, they can actually produce electricity, so they're going to create a motor today.
All it takes is a flashlight battery, a properly coiled wire propped on safety pins, then add a pair of magnets, and voila! Well, it isn't that easy. These students learned that even in physics, there's an art to science.
I can keep that in a circle and then just wrap one end like that to help secure it. Okay.
Following nearly an hour of head-scratching trial and error, one team got enough electrons moving in the right direction.
We got it! Going, 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 going.
As with all good scientists, clues to make the motor work were shared.
How'd you do it?
Well, we just followed the instruction, and I think like our fingers right here are like car keys to make it go.
No engineering curricula would be complete without some rocket science, so the university provided small rocket tubes. The students designed fins and placed them on their rockets, somewhat scientifically. The event of the day was the launch, where every proud engineer got a chance to fly, powered by manual air pumps.